Mechanical drawing. Sketch your ideal blueprint. Hello, everyone. Welcome to the micro class on mechanical drawing recognition and tolerance fit. In this lesson, we will learn about the content of assembly drawings and the steps for reading them. First, let's talk about what an assembly drawing is. An assembly drawing is a diagram that represents a machine, component, or assembly. In other words, it shows the working principle of a machine or component. The assembly relationships, connection relationships, and relative positions of the parts. It is a technical document used to guide the assembly, inspection, debugging, and maintenance of the machine, providing the necessary dimensional data and technical requirements. In product design, we usually first draw the schematic and rough draft of the machine or component assembly. Then, based on the assembly design, we draw the rough drafts of the parts. After that, we alternately improve and perfect these two types of drawings. Finally, we complete the full assembly drawing and the corresponding set of part drawings. This way, we have a complete set of technical documents. In the product manufacturing process, the assembly work of machine components must be carried out according to the assembly drawing. When using and maintaining the machine, we often need to understand the machine's structure through the assembly drawing. Therefore, assembly drawings play a very important role in production. Now, let's look at these three diagrams here. The one on the far left is an assembly of a ball valve. The middle diagram is what I just mentioned, an assembly schematic. To its right is what we call an assembly drawing. These three diagrams are closely related. Now, let's focus on this assembly drawing alone. We can see that it has similarities with a part drawing. It also has a set of views used to express the working principle of the machine or component. The connection relationships, assembly relationships, relative positions of the parts, and the structural shapes of important parts. It also has dimension annotations. But we can see that there are fewer annotations here. Not as many as on a part drawing. The dimensions marked on the assembly drawing are only the necessary ones, indicating the performance, specifications, overall size, and dimensions required for assembly, inspection, and installation of the machine or component. It also has technical requirements, which specify the requirements for assembly, inspection, and use of the machine or component. Finally, it has a title bar. Unlike a part drawing, it also includes part numbers and a detailed list. The title block indicates the name, quantity, scale, drawing number, design unit, etc. of the component. We can see that the part numbers are neatly arranged next to the views, showing that this component consists of 13 parts. We fill in these 13 part numbers in the detailed list in order. The detailed list indicates the sequence number, code, name, quantity, material, weight, remarks, etc. of each part. This is all the necessary content on an assembly drawing. In the processes of design, manufacturing, assembly, use, maintenance, and technical communication, we often encounter the need to read assembly drawings. More importantly, in design, based on understanding the assembly drawing, we are often required to disassemble and draw a complete set of part drawings. This guides the processing and manufacturing of each part and finally the assembly. Therefore, engineering and technical personnel must have the ability to read and understand assembly drawings and disassemble part drawings from them. This can also be considered the highest level we should achieve in learning this course. So what are the general methods and steps for reading an assembly drawing? Let's understand through reading the assembly drawing of a ball valve below. When looking at an assembly drawing, the first step is to get an overview. You should understand the purpose, performance, specifications, and composition of the assembly. Clarify the projection relationships and expression intentions of the representation methods. In this process, first read the title bar. You need to investigate and consult the title block and manual to learn the name and purpose of the assembly. Second, read the item numbers and the parts list. Compare the part and component item numbers with the parts list to find the positions of the parts and components on the assembly drawing. Understand the names and quantities of standard and non-standard parts. Third, read the views. Based on the view representation on the assembly drawing, find the positions and projection directions of each view, section, etc. For example, in this ball valve assembly drawing, from the title block, we can know that the name of the assembly is a ball valve. A valve is a component in a piping system used to open, close, or regulate the flow of fluid. A ball valve is a type of valve. The drawing scale is 1 to 2. From the part item numbers and the parts list, we can know that the ball valve consists of 13 parts. Among them, there are 2 standard parts. You can see the names and positions of each part in sequence according to the item numbers. By reading the views, we can see that it is expressed by 3 basic views. The front view uses a full section view to show the assembly relationship between the parts. The left view uses a half-section view with the handle removed to show the internal structure of the ball valve and the shape of the square flange on the valve cover. The top view uses a partial section view, mainly to show the shape of the ball valve. The second step is to analyze the working principles and assembly relationships. Analyze the assembly relationships and connection methods between the parts in the component. Understanding the working principle of the component is an important part of reading the assembly drawing. The working principle of the ball valve is relatively simple. The position of the valve core shown in the assembly drawing indicates that the valve is fully open and the pipeline is unobstructed. When the handle is rotated 90 degrees clockwise, that is, to the position indicated by the double dotted line in the drawing, the valve is fully closed and the pipeline flow is cut off. Therefore, the valve core is a key part of the ball valve. Assembly relationships. Both the valve body 1 and the valve cover 2 have square flanges. They are connected by 4 studs 6 and nuts 7. The valve core 4 is positioned in the cavity of the valve body through 2 sealing rings. An appropriate adjustment washer 5 is used to adjust the tightness between the valve core 4 and the sealing ring 3. There is a valve stem 12 on the upper part of the valve body. The lower part of the valve stem has a lug that is mortised into the groove on the valve core 4. For sealing, packing washer 8, packing 9, and 10 are added between the valve body and the valve stem, and a packing gland 11 is screwed in. The third step is analyze the structural shape of the parts. Analyzing the parts is a further step in reading an assembly drawing. When analyzing the parts, separate them first. Based on the part numbers, first locate the position and scope of the part in a particular view, and then follow the projection relationships. And you should use the principle that the direction and width of the section lines for the same part should be consistent across different section views to distinguish the projections of the parts. After separating the projections of the parts, based on common structural knowledge and the obscured parts of the part in that view, supplement the obscured lines and partial structures, and imagine the structural shape of the part. Generally, follow the order of first looking at the main parts, then the secondary parts, looking at the easily separable parts, and then the other parts. First, separate the parts. Then analyze the structural shape of the parts in that order. For example, the valve core of a ball valve. From the main and left views of the assembly drawing, based on the same direction and spacing of the section lines, separate the projection outline of the valve core. Combining the working principle of the ball valve and the assembly relationship between the valve core and the valve stem. Thus fully imagine that the valve core is a sphere with both sides cut into planes, with a through hole in the middle, and an arc-shaped groove on the top, as shown in the figure. After analyzing each part individually, the shapes of all the parts of the ball valve are as shown in the figure. The fourth step is analyze the dimensions and technical requirements. Based on the analysis of the assembly relationships and the structures of the main parts, it is also necessary to study the technical requirements and all dimensions, to further understand the design intent and assembly processability of the machine or component. Assembly drawings and part drawings have different functions, so the requirements for dimension labeling are also different. Assembly drawings are not the direct basis for manufacturing parts, so only some necessary dimensions need to be labeled, including specification and performance dimensions, assembly dimensions, installation dimensions, and overall dimensions. So, the specification dimension of the ball valve is phi 20, which is the pipe diameter of the valve. There are 3 assembly dimensions labeled in the ball valve assembly drawing: phi 50, H11, H11, phi 14, H11, D11, and phi 18, H11, D11. To facilitate assembly and disassembly, all 3 use a clearance fit with a basic hole system. Installation dimensions. Since the ball valve needs to be installed on a pipeline, the pipe interface dimensions M36 on both sides of the ball valve are the installation dimensions. Overall dimensions. That is, the total length, total width, and total height dimensions. For example, the total length of the ball valve is represented by 3 dimensions: 115, 54, and 160. The total width is 75, and the total height is 121.5. The 5th step is that we should pay attention to other important dimensions. Sometimes, other important dimensions also need to be noted on the assembly drawing. In addition, the technical requirements mainly include the technical indicators that the component must meet during or after assembly, as well as the requirements for the component's working performance, debugging and testing methods, and appearance. There is a technical requirement noted in the figure. The manufacturing and acceptance technical requirements should comply with the relevant provisions of national standards. The 6th step is to summarize and conclude. According to the above process, we can fully understand the structure and working principle of the entire assembly, grasp the position, assembly relationship, and function of each component, and imagine the 3-dimensional shape to establish a 3-dimensional model of the ball valve, as shown in the figure. This is the entire process of reading an assembly drawing. That's all for today's lesson. Welcome to continue following our micro class Mechanical Drawing Recognition and Tolerance Fit.